Hey everyone, this is Kyle with Simulation Lab here in Brooklyn, New York. Back again with another 3D Studio Max tutorial using TyFlow. Today we're going to be binding some objects to a moving character and then using the spline path operator in TyFlow to to link the bound particles together with some cables or something. So you can use this method for all kinds of stuff. Say like if you have an animated character or something that you'd like download from Mixamo or Human Alloy, or there's a ton of other um, really good resource websites that you can go to and get some characters, either pre-rigged. Some of them have pre-animated characters, but typically you could just download like a pre-rigged humanoid model or really any kind of rigged model you want and apply the same method and scatter all kinds of particles and bind them to an animated character. Um, so for this example, I used this method in a little intro video that I did for the Viola Art Review, which is a little series that I started on YouTube. But we'll watch the quick video. So the cell phones, there's like little smartphones with like an Instagram feed playing as like a little video file, like a video texture map. Um, and the little cell phones, the little smartphones are bound to the moving character, and then the particles themselves are linked together with like a spline path. So we'll look at how to do that sort of method, and maybe we'll take it like one step further and the splines that are connecting each particle, maybe we'll have those drape or have those like be kind of flexible or something. Um, so we'll jump into Max. I have the character pre-animated, and of course you can animate one yourself. I think I downloaded this from oh, I downloaded this model from renderpeople.com. It's one of the free models that you can get. Um, all of their models are pretty high quality. The textures are pretty good. They're like actual like photo scanned people, photogrammetry scanned people. And these ones are pretty great because they have both cat rig and biped options that you can use. So this is just the standard max biped that's used to rig this character. And then I just put on a like a simple little biped movement file. That's just a little dance routine that he does. Does a little ballet routine. There you go. Yay. And you could tell like the weighting is not so great on the actual rig or the skin itself. It's not really weighted all that well specifically for this animation. You could tell there's some like really weird deformation happening in the mesh, but we don't really care about that because we're going to hide the character and basically just all we're focusing on is scattering particles on the surface, binding them to the surface, and then ultimately we'll be rendering those particles like we did in the example video. So let's jump in. So now that we have this set up, I'm going to grab my one of the bones here and put him in a standard T-pose just so we can scatter some particles and we don't have to worry about the animation for now. So I'll grab his character under object properties. I set it to not renderable already, and you can do display as box if you want. So now we're just left with the bones, which that's cool. We'll keep those there for reference as reference just for now. So first things that we want to do is I'm going to go ahead and create a new layer. I'm just going to name this particles something. And we'll create a new TyFlow object. Put this one off to the side. Stretch that out for you. Okay, good. So first things that we're going to do is we're going to birth some particles at frame 0 and maybe we'll do like 50 for now. And we're going to display those as geometry. And then we're going to do position object. And we're going to pick the skin. So now you can see that there's particles that are being scattered along the skin itself. Um, and just so you can see them a little better, we're going to toss in a shape operator. And I'll set this to a low-res geosphere for now. And maybe scale that up to like 500. Okay, so now you can see them. But the issue is that this totally works for scattering things on a static surface. But if you have an animated character, let's just like turn our T-pose off. So now wherever the character is at frame 0, it's going to spawn, or it's going to birth the particles on the surface, but you could tell that once the animation starts playing, the particles just stay static wherever they were birthed at frame 0. So we don't want that. So what we want to do is, this is actually pretty simple. We're just going to do an object bind. Do an object bind, and we'll pick our skin, and we'll set this to, make sure that's set to continuous. And then we'll do lock to surface and snap to surface. So now when we scrub our character, when he moves, the particles stay bound to his the surface of his skin. So that's pretty cool. That works pretty well. And I think for now, for this tutorial, we're just going to keep the objects as spheres. You could do anything you want. You can replace, you can put whatever you want in the shape operator. You can reference any kind of geometry, like in the example video I referenced just like some cell phones. It's like really simple little cell phones that I modeled really quickly, and then I just put on some texture maps on them. So you could replace that there, and then so now that you have this set up, what we might want to do is we'll do a physics shape so they actually collide and stuff, and then what we'll do is we use physics to have them have a little bit of collision, so they kind of run into each other if they're in proximity to each other. So that'll sort of help with that. And then what we'll do is from here, so we'll mesh it and click render only, and then we'll do a spline paths, and then we'll do in spline paths we'll do neighbors, and then create new. So that what that does is it creates a new spline path operator. You can see the splines are already being generated, but we can go under TySplines and max neighbors. And we can increase the distance threshold. So now if you're familiar with like, there's like certain tools in After Effects that give you this thing called a plexus. Basically what that does is just binds the approximate neighbors with a spline. So if we scrub this, and for this example, the physics operator isn't really necessary. What we can do is over time we can birth some objects coming off of him. So we can disable that for now. Okay, so one other thing you can do here is if you wanted to have like some extra particles like falling off of the character as he like walks or dances or whatever, what you could do is you could do a spawn, spawn maybe do like per second. For now, we'll just do like 1 per second or something, and this is going to spawn it at the location of the position, the parent particle position. So it's going to spawn it at the locations of each particle. So depending on how many particles you have, it's going to be quite a bit of extra particles that are spawned. So what you could do is, just for testing this out, you can hook up a physics shape. So what this will do is if we run this um, as the character's moving, it's going to be spawning particles and they just fall to the ground, which is kind of cool. And so if you want that sort of effect, you can, play around with the number of spawns that it's producing, and you could also um, set up specific locations around the mesh for it to spawn, for extra particles to spawn if you're into that sort of effect. But for this example, we're not. I don't necessarily want to like generate any extra particles, so we're just gonna get rid of that for now. But just note that you can do that. Um, okay, so for this is looking pretty cool. I think what we're gonna do is increase this. Maybe I'll do like 100, um, and then from here, um, what we can do is, let's say if I wanted to actually simulate the splines having a little bit of like flexibility and maybe treat them more like a I don't know, like a wire or like a cable or something, like wires that are like connecting the spheres together and they kind of just like wiggle around. They're affected by gravity and stuff like that. So one thing we could do is set up a separate flow that controls um, the actual splines themselves. So if you want to do that kind of effect, I don't know a way to do it in the same flow. Like say for instance, if you try to birth spline or whatever, and you try to pick that TySpline object, it won't allow you to choose it. And I think it's because it's being generated from this flow, so you have to do it in a secondary flow, secondary event. So drag this off here, and then what we'll do is create a second TyFlow object here, and then what I'm gonna do is in my TySplines, I'm gonna reduce the amount of splines that are being generated. Um, so maxed instance, will reduce this a little bit just for clarity's sake. Um, so reduce that a little bit, and then in my second flow, I open this guy up, right? And we have an empty flow. We still have our first one, and we're going to be referencing the splines in our second flow. So drag this up, and we'll do birth spline. We don't really need to see the entire graph. And then we'll pick our TySplines. There you go. And then in our layers, we can turn off our original TySpline. Um, and you can see that we just have a series of particles that are connecting the spheres together. And we scrub, nothing really happens. They don't move because they're basically just spawned at the location of the original splines. So we have to give them something to do. Um, so from here, we can do particle bind. And we'll choose stiffness affects inertia. And we'll set the stiffness to like 1. And then down in our proximity bind, we'll turn that off. And we'll turn on bind to siblings. Bind to siblings and bind to parent. And we'll keep bind all on. So what that'll do is that'll just bind the particles that are generated along the splines together. So they'll kind of act like a continuous spline once we add a second TySplines operator in this flow. So basically just replacing the original uh, spline paths operator from this um, event. So we're using this basically just to generate the geometry and generate the original splines along the geometry. And the second flow is what we're going to be using to actually give some physics um, behavior to the splines themselves. So we're basically overriding the original TySplines operator. So from here, we could do is like a surface test. Surface test. There we are. And we'll choose our original TyFlow object because we're going to be testing the surface. If it's inside, or we'll do distance, and we'll just do like a if it's greater than like 1 centimeter, then we're going to switch the particles off. We're going to deactivate them and bind them to the spheres. Object bind. I'm going to pick the TyFlow object. So that's basically binding the. Basically, we're just disabling, like whenever it does a test within the proximity of 1 centimeter to the original spheres, um, the particles that are being generated along the original spline event are disabled from the overall bind, and they're then bound to the spheres from the original flow. So what that gives us is, well, I think for now, what we'll do is we'll apply a force so you can see what's happening. So we'll do a force, we'll do gravity of 0.5 or negative 0.5 or something. And then if we, and what we'll do in here is we'll create another TySplines event, spline paths, and then we'll create, and then we'll do particle bindings, and then create new. Okay. So, and then for this one, then we can increase the radius a little bit, and we can turn it on. Increase the radius a little bit so you can see what's happening. And then we can kind of scrub this one out and see how it works. Okay. All right, so you see what's happening is it's being disassociated, so obviously it's not working. And the reason why that's happening is because we need to, in our original flow, add in a mesh operator. So when we do that and we turn render only off, what that'll do is it allows the second flow to understand that it's that there's some actual geometry that is overlapping. So from here, we can tell that there's like some dead ends here. So what we can do is copy this spline paths, paste it in this other little operator here, and then that is looking pretty good. And then from here, we could do object bind. We can do lock to surface and snap to surface. So that gives us a pretty clean little connection between uh, each of the spherical particles. So that's kind of cool. And then what we could do is maybe scrub this out a little bit and see how it looks. So that's kind of getting this like cool looking catenary curve to the particles. And what we can do is in our display, I'm just going to turn off the bone objects just so we see the character with just the particles and splines. And then what we could do is we can grab this splines object here, and we could do under TySplines weld bindings, and you can even weld knots if you want to. So you can get this to be a lot cleaner, but this is just sort of an example. What this is doing is basically it's binding the position of wherever the distance is to the sphere. It's binding those particles from the spline event to the spheres. So what we could do is surface test distance. We can reduce this a little bit, maybe 0.2, 0.1, something like that. So you could play with that and adjust how the splines are interacting with the spheres. But it just takes some tweaking to clean this thing up. So now that we have that done, it might increase the particle size a little, increase the particle count a little bit, maybe something like 200. That's pretty cool. And then you could just kind of play with this forever, and you can oops, turn down the radius a little bit so they look like more like cables, or maybe you can have like a guy who's like a living chandelier or something. I don't know. Um, but the important thing here is that when the character moves, I'll go ahead and scrub this out so we can see what's actually happening. That the particles stay bound to the spheres and they kind of move and they have physics applied to them. So what we could do from here is, that's looking pretty cool. So when he moves, the physics of the movement and the inertia of the particles moving have an effect on the actual cables. So they're kind of dangling there because of gravity, but when he moves around, they kind of like fly around. So you can have it'd be kind of cool if you had like if you replace the spheres with like little electronic devices or something that are connected by wires and move around or something. I don't know. So the possibilities are really endless with this sort of thing. But from here, what we could do is in our original TyFlow event, we could export particles and we can kind of cache it out. Um, let's see, maybe we'll do like 100 frames. And we'll put it in a TyCache object. We'll pick where we want to put it. C1. So this will be our TyCache for the particles themselves. And then we'll go ahead and generate that. Okay. And then we'll disable. We'll keep that on for right now. And then we'll do the same thing here. Export particles, but under general geometry settings, we'll do spline path geo, and then we'll set this again to 100, and we'll choose our output path. So put it in here, C2. Frame range 100, spline path geo. Okay, and we'll generate that. And this will take a little bit longer, so I'll pause the video and we'll resume when this is done building out the cache. Okay, so that finished exporting. Now what we can do is disable the flow. We can disable this one, and we don't really need this anymore. Now what we could do is, in our particles, we can hide our previous TySpline object. Actually, we could hide all this stuff, but we'll keep the caches visible, and we'll go ahead and scrub along this. And it still takes a little bit of time to scrub. It's not like super real time, but it definitely is much faster than having to process every frame. So that's getting pretty cool. I'm not exactly sure why you would want to do this, but it's kind of a cool effect. Um, so like the splines kind of get knotted and twist around and stuff. And one thing we could probably do is add a physics collision operator to the spline event to get the splines to actually like wrap around the spheres. Because you could tell that they kind of wrap around, they kind of continue to bind to the spheres, which maybe we don't want that to happen. We want to keep them like loose, um, so when they actually do collide with the spheres, they don't automatically bind. And one thing we could do is, for instance, in our original object, we can do, okay, so this is set to on entry event particle bind. And then surface test, instead of continuous, we could do on entry event only. So what that'll do is that'll just bind on entry event the particles that are in the sphere itself. All right, guys. So I disabled my TyFlow objects. I got the caches built out. Um, the second cache here over the splines, just make sure that you include spline path geo. The cache itself for this particular flow was about 2.5 gigs, so it's a pretty heavy sim. Again, you can adjust all this stuff and you know do whatever you want to the actual TySplines before you export the cache. So we can go ahead and scrub through this and see how we're looking. I got my original TySplines hidden so we don't see that. And if we scrub through this, it's looking pretty cool. Um, got the spheres bound to the character so they move along with the character's mesh, and then in between the characters, like while the character's moving, there's the interpolated splines, and then there's physics being applied to those splines. So as he's moving, there's gravity that's being applied to it as a force that's set up in our TyFlow, and then um, the movement of the actual spheres that the splines are bound to affect the inertia of the splines in the second flow. So that's pretty cool. Um, like how this is looking so far, it's pretty dynamic and fun. So so yeah, that's pretty much it for this tutorial. If you found this helpful, I hope you guys did. Um, there's plenty of methods you could, there's plenty of things that you could apply this to. So I'm looking forward to see what you guys create. Like I said, you could like maybe use these as like cables that bind together some cool like electronics or something that's bound to the character. I don't know. Um, plenty of stuff you could do with this method. But if you found the tutorial to be helpful and if you liked it, please smash the like button and subscribe for more. And let me know what you thought of it in the comment section below. If you know of a different way of doing it, or if you use this method for for something, I'd like to see what you did. Um, yeah, uh, thanks so much for watching, and we'll see you soon.